2017 probability, Connor rings Kira's house. The probability that she answers the phone is 1 over 5. He rings her house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, 4th and 6th, but not on the other days. So this is specific. In the second part, we just jumped down here, the probability that she will answer the phone for the 4th time on the 7th day, you're going to recognize as Bernoulli or Bernoulli, however you want to pronounce his name. So in the first one, you can see here, answers the phone 2nd, 4th and 6th. So that's 1 over 5. The probability she answers the phone is 1 over 5. So 1 over 5 to the power of 3 by 4 over 5. She doesn't answer the phone on 4 of the days. So 1 over 5 to the power of 3 by 4 over 5 to the power of 4. A small number 0.003 2768. 32768. The 4th time on the 7th day means that there was 3 answers in the first 6 days. So the probability of success to the power of 3 by the probability of failure also to the power of 3 by the probability of answers success on the 7th day, which is 1 over 5. And if we type this into a calculator, 6 use 3 is 20 by 1 over 5 to the power of 3 by 4. It's 20 by the first answer actually. No, it's 1 over 5 to the power of 4 here, so that's going to give me 0.01 638. There's a 4 there. Just be careful typing these into your calculator, that's the only thing. He rings her house once every day for n days. Right, in terms of n, the probability she will answer the phone at least, anytime we see at least once, it's 1 minus the probability of none. In this case, at least once is 1 minus the probability of none. So what's the probability of none? So imagine she doesn't answer the house on the first day, it's 4 over 5 to the power of 1. Never answers the phone, it's 4 over 5 to the power of n. So 1 minus 4 over 5 to the power of n is at least once. And then the minimum value for n, when this looks like a log question, when we start seeing these types, the minimum value for n for which the probability that Kira will answer the phone at least once, so using the previous information, is greater than 99%. So 1 minus 4 over 5 to the power of n has to be greater than 0.99. Now you can, when you're bringing that logs, you'll sub these down quite quickly, but I'm going to leave it as minus 4 over 5 to the power of n greater than 0.99 minus 1 minus 4 over 5 to the power of n greater than minus 0.01. So now we have to change our signs and flip our inequality. So 5 over 5 to the power of n less than, now we're going to have to change this inequality again in a minute. We'll see why when we're dividing by a number less than 1. So n by the log of 4 over 5, I'll change it to 0.8 at this point. Have to be less than the log, 0.01, getting the log of both sides. Now this guy here is less than 1. Sorry, is a negative number. So we got to, when we divide across by the log of 0.08, we're going to have to change the inequality again. So the log of 0.01 divided by the log of 0.8 is going to say what n is greater than. So n has to be greater than. So n is telling me it has to be greater than 20.6377. N has to be greater than 20.63. And n is actual number. So n in this case is equal to 21.